Hi everyone, welcome to my presentation on the final project on SIT 123 data capture technology. So this project is on testing how often I should water my plant. And here is a description of the project. Different plant needs different frequency of watering. How to determine how often you need to water your plant by monitoring the patterns of how quickly the soil moisture drops after you water it. So I watered my plant right before the test, and then I set up the soil moisture sensor to be buried just below the soil of my plant. And then in the next 10 days, I did not water my plant, and I collected the data of the soil moisture collected from the Arduino board. The hypothesis being tested is that I need to water my plant about once or twice a week. I want to know how quickly the soil moisture drops during the 10 days. And once I know how frequently I should water my plant, I can then set up an alarm on my phone to alert me when I should be watering my plant. Now, here is a detailed description of the approach. Firstly, the required hardware include Arduino Uno board, data logging shield, SD card, jumper cable, power supply, soil moisture sensor, USB cable. And required software include Arduino IDE, external libraries, RTC library. And here is a schematic view of the softwares and hardwares and interconnection between them. So firstly, you need to insert the data logging shield into the Arduino Uno board, and then you need to insert the SD card into the data logging shield. And when you connect everything together, verify the code and test it before you set up the final device. So the third part is data collection process. So the first part of the data I collect is that I kept a journal of the plant conditions for the 7 days. So I use the scale from 1 to 10 to denote the health condition of my plant. I also keep a record of the weather, as I noticed that on the rainy days, the soil moisture might rise for a short period of time even though I did not water the plant from my previous testing. Now, here is cleaning data and data integration. So after collecting the data for 10 days, I changed the CSV file into Excel file, and I used the filter and sorting to detect any null values or blank rows. However, I did not find anything like that. Therefore, I used the filter to check every day the data included in every day. And I find that on 17th of September, there are only about 1 to 2 hours of data collected, and compared to the rest of the records, it's such a small sample that it will not accurately represent the average soil moisture that I will use for this test. Therefore, I delete the 17th of September data on the Excel. So here is an evidence of the data I collected. The first part is the journal I kept for around 10 days. The second part is the raw data collected by the Arduino board. And here is the final visualization from my Tableau. Both of them are representing the soil moisture changes during the 10 days. When I try to integrate the data together, I use the outer join in the Tableau to join both of my Excel tables together using the unique key on the date. And if we look closer, the first visualization shows that from 7th of September to 16th of September, the average soil moisture drops along with the day passed. Also, on each of the day, I have labeled the average soil moisture. On top of the average soil moisture, I have also used the mark for the average plant condition that I put in my daily journal. So therefore, you see that from the green to the right, the plant health condition drops when the soil moisture drops. The second diagram shows that for the 10 days, each line represents 1 day. It shows 24 hours how the soil moisture is changing according to the hours. I also mark the weather conditions on the right-hand side. As you can see, on the first day, on the 7th of September, the soil moisture actually temporarily rise. It is because of the weather condition. Ethical concerns of the project. Privacy issues. Since the plant was inside my own room and not in any public or common area, I don't think I have affected or might invaded other people's privacy. However, I do have a concern if I were to publish this data online. This is because it is possible that other people might be able to detect where I live by analyzing the weather conditions that I provided along with other informations. So I think this is an important concern, and I will keep that in mind. So the final result. So I do have some reflections on the scope and accuracy of the proposed solution and the devices and systems. Since I only have collected data for over a week's time, I think this exceeds the minimum of 3 days required for this project. I think the accuracy of the conclusion that's being drawn for this project is pretty accurate. Moreover, I kept a journal to keep a close eye on other factors that might influence my data and conclusion. So with all the analysis, I have come to the conclusion that watering my plant about once a week is enough for my parlor plum. The challenges and lessons I've learned. One of the challenges include that when I was testing the whole system before the final testing, I found the soil moisture increases without me watering the plant. I was originally worried if my sensor is broken. However, when I tested for over 2 days, I realized that the soil moisture does drop during the 2 days. It only raises temporarily when it is raining outside. Another challenge is that I found it quite difficult to connect the two datasets together in the beginning, and later on I have found a way to use the outer join to collect the two tables together and then visualize with a few times to put as much information as possible, but also keep the information and message very clear. The proposal for further extension of the project. Since soil moisture is influenced by weather conditions, and I think it is for the future extension of the project, it is better to put this plant in a lab condition. So in a lab environment, we can control the temperature and room moisture, so we do not need to consider any weather conditions. I also reflect on the scope of this project. Although I collected 10 days of the data, which is quite a big amount of data for this project, I think that I could actually collect more data for more conditions, such as if I use 50 millimeters of water instead of 80 millimeters of water, what will happen to my plant? What about 100 milliliters of water? So we can create test A, B, C, D using different amount of water, and then test them in a period about 10 to 14 days to see how much water I should water the plant every time. And also, as we know that the plant grows differently in different seasons, and it might require water slightly different. So I think all these considerations need to be taken into account in the future extension of the project. In general, I think my Arduino project has been proved very successfully. I have learned how to use Tableau, and how I have spent quite a long time testing how to visualize my data in a very informative way. And also I spent a long time creating this visualization of my final poster, and I really hope that you enjoyed my presentation and my project. Thank you very much.